Sound check. One, two, three.
Sound test 1, 2, 3 with the mic.
Good. Welcome everybody to today's .NET Meetup, September 2022 meetup. thank you all for joining here at location and also the people watching on stream. As always, the .NET meetups are organized by us. Who is us? We are the .NET Devs AT. We are a non-profit organization here in Vienna, which our goals are making it easier and have some space, some time to exchange knowledge of us .NET developers and knowledge sharing, experience sharing, all that around. We are all over the web. We have a website. We're on Twitter. Some of you are watching Twitch and YouTube currently, and also we have a Slack channel to help each other out if necessary. And with that beginning, I hand over to Mark. Yes, some small housekeeping rules.
Yeah. Welcome everybody to Dynatrace. So today I'm just going to say some few housekeeping rules and then hand over to Joao, who's going to give the main talk. First and foremost, everybody of you got a white entry card. If you leave, please return it at the front desk. There's a small thingy where you can put them in. There's a post-it says, please return cards here. They only work once, so there's no reason to keep them in their blankets, right? The elevators, please make sure that to remember that if you're going down, you might not be able to get up again. So if you want to take a smoking break or something like that, please just let me know and I will come downstairs with you. Bringing us to the next point, please no smoking inside the office. Don't open the windows. We have tried and it makes terrible air conditioning happen. So yeah, the windows don't go to outside. They just open the hole to more ventilation that is being passed up from the other floors. The toilets are over there. Photos will be taken for social media, so just a disclaimer there. And other than that, just have fun, enjoy the snacks, which will be coming out after the talk, and the beer, which you can find in the after-work fridge. And with that, we'll just tell you something quick about the company. We're a software product company founded by Bernd Greifeneder in 2005. Our R&D headquarters is in Linz, but we have offices all over Austria and also North America as well. And we are an all-in-one software intelligence platform. We basically provide automated full-stack AI powered coverage, and we have over 3,000 employees worldwide, out of which 700 are in Austria and quite a few in Vienna of that. So yeah, that is it. Other than that, there's one thing, we're hiring. So if you're interested, you can just approach me or scan the QR code and I will be able to refer you to the right person. And with that, we can move on.
It's still me. It's still me. Still some introductions. So thanks to our sponsors, thanks to Dynatrace for hosting us today and also providing the speaker. We have also other sponsors. We have Rubicon, Theater Every as financial sponsors, and also JetBrains. From JetBrains, we get a 12-month product license that we can raffle here, and we will do this today. So I have one voucher for a license that we will raffle at the end. Some quick news from the community. This meetup is part of the .NET Foundation, and the .NET Foundation is hosting a .NET Foundation. We have this virtual user group where a lot of user groups around the world are publishing their events, what they are online only or also additional streaming like we do. So if you want to consume more .NET content, that's a good place, and probably some on stream found us this way. One thing one partner meetup of us, the Unity meetup, the Unity 3D engine. They have on September 27 their next meetup about compute shaders. Yeah, you find it on me.com. And then the last thing before the talk, started to recommend some .NET content creators, all about knowledge sharing at us. So first one is our Stefan Flashaware. He's always streaming Sundays morning. Still .NET source generators.
Rostling components in general.
Rostling components in general. Second one is Claudio Bernasconi, content creator from Switzerland. Really good starting content. And then we have also Nick Chapsas from UK, who produces very cool, more level 300 content, I would say. And with that, I hand over now to our speaker, Joao, with modern observability for your .NET apps with OpenTelemetry. Your stage.
All right, so I'll say my thanks again for everybody that is joining online and also here. I hope you can hear me. I'm not much of a loud talker, but I'll try my best to speak loudly. Right, so this will be the talk today, no surprise. So let's learn about what you can do or what is there for making your .NET apps modern and observable. Okay, so a little bit about myself. I'm doing .NET since 2012. I think my first thing in .NET was Silverlight. I worked on a Silverlight app. About a year ago, I decided to do some changes in my let's say career. So I don't do .NET too much anymore. I joined Dynatrace a year ago, where I work full-time on contributing to OpenTelemetry. So we are a team of engineers that contribute to everything around OpenTelemetry for the specification, for the individual language projects and things like that. So, but I still really like .NET. So I, with the help of a friend of mine, I helped creating this project, NuGet Trends. I don't know if you know about it, but it's a website where you can see the download rates of NuGet packages. So if you don't know, there's a link. We'll share the slide somehow afterwards, so you can check it out. I used to have a blog, but there was some issues some time ago with some privacy things, so I shut it down for now until I figure out what to do. But I also plan to start a series of blog posts on OpenTelemetry for .NET. So stay tuned. And I probably enjoy memes too much, so there will be a few in the meetup. So I hope you're not bothered by it. All right, so there's quite a lot of stuff to cover. So the agenda is more or less this. So first we'll start kind of grounding ourselves to see like why we care about this. Why did you come to this talk? Why is this topic important? Why should we care? And then we'll move forward to something like what is the usual way of troubleshooting your applications? And then we'll see what their limitations are. And moving on, we'll see some terminologies, what current tools are there, also their limitations, and we'll tie together how this new observability thing that you might have heard of can help. Towards the end, then we'll see, I'll show you how what OpenTelemetry is and how it connects to .NET and how can you use it. I plan to show you some live demo. Hopefully it will work out. I have a plan B if it doesn't work out, so we'll see. And then hopefully we'll have some time for questions in the end. Okay, so the first thing is like why we care about this topic, right? So I imagine that everybody that is joining this event here wants their software to work, right? So nobody probably likes bugs in their application, right? Nobody wants to be waking in the middle of the night with an alert or something, right? So, but like the other important thing is that we know that problems will happen, right? So there's always some problems, like no matter how diligent you are with your software development lifecycle, there will be some slippery, and you find yourself in a production issue, right? So it is important to of course, always want to have things working, but it is always also important that we have the tools when things go wrong. So like we have the tools to troubleshoot, to identify problems. So we are confident that when, for example, we deliver a new version of our system, then we are confident that, okay, if something happens, then I'll find a way to, I'll have the necessary tools to troubleshoot and to fix it. So let's see what might be a common journey of troubleshooting your software. So I did some drawings. I hope you like it. I'm not the best drawer, but so the usual way, and this comes from my own experience. As I said, I worked as a .NET developer for quite some time, and also reading and talking to other people. So usually what happens is maybe you already have some sort of indicators in your infrastructure, maybe some metrics, for example. Maybe you already host your applications on some cloud provider, and let's say for example Azure or AWS. Maybe they already give you some indicator, for example the HTTP error rate or the CPU usage or things like that. So it kind of always starts when you get an alert or you just stumble upon the dashboard or your metrics dashboard, and then you say, okay, there's something really wrong there, right? There was a spike, and then okay, let's take a look what happened. So usually then I relied heavily on the past with logs. So you go look at the logs, right? So yeah, let's show me the logs in this time frame here. And then maybe you find something, maybe you don't find anything. It's like, okay, I have to step a little bit back more. So you move to, let's say, 3 hours. And then you still maybe don't find anything, right? And if you're lucky, you already have, for example, your logs in the same place where your metrics are. Or if you don't, then you have to do what people say, like tab-based debugging or something, because you have so many tabs open, because you have used different softwares for different things. And this is all if you're already, let's say, lucky that you have already some tool in place. But there's quite a lot of people that, for example, have their logs still in the console output. They have to log in into the containers to see the output, or go to the Kubernetes and see the log. So does this sound familiar to you? Look, as I said, it does to me. So I did this for sure in the past. And like if you have, like, say, it's a heavy word to say simple systems, but if you have something that is small, maybe that approach works for you, right? Maybe you host everything in the same server and just look at the logs might help you troubleshoot things and find things quickly. But like nowadays, not everything is that simple, right, anymore. So I think the age of hosting everything in the same IIS server and the same database, the same server, it's probably gone, right? So we have distributed systems. We have everything is in the cloud. We have to maintain high availability and all that stuff. So even if you have something like a small, let's say, photo upload app, you already have to like rely on so many third-party providers. Your database is probably in the cloud. Your messaging system is in the cloud. Your feature flag provider is also in the cloud. So everything is already there. So even if you just have a simple app that just uploads a photo, you're already dependent on so many things that can go wrong. So, right? So like with a simple app, it is possible to do that, but it's not great, right? But when you step into, let's say, more distributed apps, for example, like this, what do you do then? Like, how do you even, like, how? Like, I don't know, just send help. I don't know. Like, this is an actual service map diagram from Uber. There's a link in the slides here once you reach it. So what do you do, right, when you have this? This is not simple anymore, right? We can't just retrace the steps in our mind, just look at the logs, right? You need to have something better than this, right? So what kind of tools, right, do we have? So we already briefly talked. I told you about logs and metrics. So what else is there, right? Or can I use these two things to help me figure out this chaotic situation, right? So it's all about telemetry data. So we have, so our systems, our applications, they produce a lot of data about themselves, right? So for example, logs and metrics. So those are characterized in the observability world, let's say like that, as telemetry data. And we already talked about metrics and logs, and there is another one called, that you might have heard of or might not, this called distributed tracing. So let's take a look at these topics, these concepts, figure out some terminology so we have a base to move on, right? So the first one that you probably are familiar with is logs, right? So logs are like the basic, is the bread and butter of software development, right? Like all of us start developing, we write console logs, hello world. So they are really easy to get started with. They offer great granularity for things happening in your systems. With the advance of structure logging, it's even better. You can attach payloads to it, metadata to it. And there's quite a lot of advanced tools for doing like log search and things like that, right? But the problem with logs is that, for example, in a distributed systems, you have several components produce different streams of logs, right? They ship their logs, but there's no really way to correlate them. In .NET, you might be familiar with this correlation ID that was a thing in the past, or maybe it is until today, I don't know. That kind of offers you, but there is better ways, we'll see. So logs, yeah, there's not much to talk about. They're really useful, but they only go so far, right? And again, like if you're lucky that you already ship them in a way that they're together aggregated, otherwise you're lost, right? You have to log in into different containers and SH into different boxes to find things out. That will be a nightmare, I guess. So the next telemetry data that you might have heard of is metrics. So we briefly touched about it. So metrics are pretty much like also somewhat the bread and butter. Like I said, even if you don't even know what metrics are, you probably already have them because you host something on Azure or on Amazon. For example, if you host your apps on Azure on App Service, you already have the HTTP error rate, you have CPU, you have memory, and maybe other stuff as well. So metrics are very popular in dashboards. So you probably maybe also seen these fancy dashboards with all the overview. And they're good because of this. They offer a very good overview of the overall health of your system, right? So you can just look at it and see how things are going. But the problem with them is this, right? They only tell you at that moment of time, like this, it was like, oh my God, there was something was terribly wrong here. But that's it. Like you don't know anything else, right? You just know that at that point in time, something went kaboom, and that was it, right? Like you can tell, it only tells you like once upon a time there was this, and that's it. And when I tell metrics here, you might know about, for example, think about like CPU usage or memory use, but there is also other types of metrics, right? You can create your own, for example, to track business-oriented metrics. For example, I want to know, I don't know, like how many customers are in my store right now, right? Like physical people are in the store, and many things, right? Or I want to count, for example, how many items are pending in my queue to be processed, something like this as well. Yes, and the next telemetry data that this might be a little bit more esoteric, you might not have heard of it, is distributed tracing, and or also known as traces as well. Let's just use traces for now because it's shorter. So there's different ways of explaining traces, but the way I like the way I learned it and the way it makes sense to me is that a trace, like you can think of a trace as a way of correlating and aggregating all the operations that happen during one transaction. So a transaction can be, for example, a user clicking a button in your web application. So from the moment that the user clicked that button, for example, to buy something, a myriad of operations was triggered, right? So there was calls to different servers, there was calls to the database, and so on. So in a distributed traces, you can have all these operations linked together in a Gantt chart, more or less like this. And this offers you an immediate view of everything that happened during that transaction. So all the operations are correlated like that. And each individual block, that, as you can see in the slide, so the green block, the orange ones, those are referred to as spans. So this is a concept that you might heard about as well. And it's quite nice because a span actually means because it spans across time. So you can see, for example, the post for the profile API, it roughly took like, I don't know, 300 milliseconds, right? So you can just look at it and you can see, right, which operation took more time in my infrastructure. So these are like the very high level of distributed tracing. Just an aside here, there is a concept behind it. So how does, you might be thinking, like, how is this possible, right? So, and I talk about this correlation ID that used to happen, it used to be a thing in .NET. So all this is possible again, in a very, very high level, because this topic could be a meetup or a talk on its own. All this works because there is a concept behind called context propagation. So the way it works is, for example, in the profile API, the profile span, let's think that is a JavaScript application, a client application. So from the moment that the user clicked something on the JavaScript application, there was some IDs generated, and those IDs get passed on to all the calls that goes on and on. So, and this is how this propagation happens. So each component in your infrastructure, in your system, receives these IDs, start a new one, pass it on. Receive, start a new ID, pass it on. So that's how it works. Again, it's a very, very high level, but it is a topic or something that you might stumble upon. So that's how it works, more or less. And traces also give you a nice view, like you get kind of this for free, that you have this sort of map, like we saw the one from Uber. You get a service map, maybe it's usually called like that. There's different ways to call it, but it's a map or it's a dependency graph, or that you can see, for example, from your app. So you can see that the profile service depends on blob storage and a service bus, and it talks to an alt service, and the alt service talks to a SQL database. So you get this for free because you already have this mapped. You have all the service that is part of your infrastructure, how they talk to each other, and you can even do cool things. For example, like there's I'm not sure, it's maybe not the best color I chose, but the line for the alt service to the database is red. That means that there is a lot of failing requests, for example. Then you can have this sort of things in your platform. So like in your observability backends that you use, they can do this. And talking about individual operation, like we saw, so like I told you already, each operation in a trace is called a span, and a span has a lot of details about it. So because it happens during a context, for example, when in your .NET, in your ASP.NET API, you receive a request, right? And we are all familiar with the HTTP context, right, that we have in our APIs. In the HTTP context, we have a lot of information, right? We have, for example, the user that is logged in, maybe some parameters, some query parameters, so payload, whatever. Like there's many things that happens during the request context, and all the information can be attached to a span. So when you're debugging, when you look at it, you know, for example, in this case here, I had some examples. You know, for example, which service was that? What's the service name? What's the HTTP method? What's the URL? What was the status code of this operation? And you can have many things. You can have events. You can have logs. You can have also exceptions attached all to the span. You don't have to look into a different system. You don't have to go anywhere else. You click on it, and you immediately see all this. And we'll see a demo of how this works. And here on the top, you can see the IDs that I mentioned that are part of this context propagation topic. So they're all there. You have this long trace ID, it's called. That's the responsible for continuing all of this to make possible that you have this continuation of things. Right. So I don't know. You might be feeling like this right now, right? So you might think, oh, this looks quite good, right? I really like to have all this in place so I can debug my apps better, right? That's what I basically just said. Except for, it's not because, like, if you use these things already immediately, let's say you go and install this and you make this happen, right? So it's not gonna create you any solution. It's not gonna solve all your problems all of a sudden, right? The problem with this is that what often happens is that people install, have all this, but they are used it like this, right? They are still separate things. They're on their own stream. You still have to go separate to look at them. So this doesn't solve anything, right? It's just more data. It's just more information for you to go look at. You still have the tab-based troubleshooting. So this is not great, right? Because you just add more stuff, but doesn't really solve much. And this is where observability came in. That's the topic from one of the topics from the talk, right? So what observability really means. So it's a very overloaded term. There is not really like a precise definition, but observability really means that, so first it comes from a very theoretical things called the control theory that basically tells you that you can tell the state of an application by its outputs. So based on the outputs, so that all the telemetry data that we just discussed, based on all that stuff that your app emits, you can pretty much find out how it's behaving, what's its state. But in like simple words, what observability really does is it help put things into context. So you are not anymore doing like the manual thing. Things are in context, right? So you can jump from a log to a trace, from a trace to a log, and see all things connected, right? And what observability helps you then, if you look back on our initial example that we had, so observability shifts this sort of troubleshooting from this to something like this, right? So it's kind of similar, but we still, for example, start from a metric, right? That went kaboom. Let's say HTTP errors. Then from that metric, for example, you click on that and you go, for example, to a trace. And then in the trace, as we already said, we have the operations, right? And we immediately can see that this took too long, took more than 1 second, so it timed out, for example. And then say, okay, the alt service there, it's a bit taking too long, so what happens? And then you click on that and you see all the exceptions that's being thrown, because it's the same UI, as I said, the same view, right? And you see a lot of, for example, token invalid exceptions, like, what's happening here, right? This should happen, and then you say, okay, let's see who is the producer of the tokens, the alt service. Let's look at them then. You go in this investigation, right? You're like a Sherlock Holmes. And then you go there and you say, okay, let's look at the events of this as well. Again, no having to filter time zones or time spans and figure out if you're in the correct time zone or something like that. Then you already see, for example, there was a lot of events saying that the alt service got its new signing certificate. That's why all the tokens are invalid now. So there you go. Like, you don't have to jump around. You also, what's very important here is that you don't have to necessarily have a lot of context in the app that you're debugging, because in the previous example, for example, if you just see a log line, if you're not the engineer that worked on that code, if you're just, I don't know, you're like a software reliability engineer as an SRE, you just see a log. I mean, it's just a message for you, right? You don't really know what that means. But if, for example, the engineer that worked on that code see that log line, it's like, oh no, that's really bad, right? If you reach this part of the code, then we're doomed, right? So you need to have context when you're doing the other way, right? You need to know that if the code path reached that point, then something's not right. So this way here, you don't have to do that to have that knowledge necessarily. And you also don't have to correlate things in your mind, right? You don't have to know that this log line here is related to this log line here, then related to the other service, and so on. So it's already done for you. The machine does it for you, right? The computer does it. You don't have to do it, which is great, right? This helps us tremendously. Okay, so you might be saying as well now, okay, I'm so dummy, like how do I start with this? It's really simple. You just go to the Cloud Native Computer Foundation landscape page, go for the monitoring and logging and tracing, and pick one from here. Isn't that great, right? It's amazing. It's not really a lot of options. You can just pick one. It's fine. So that's might be you right now, feeling like, okay, like I'm a bit overwhelmed at this point. Like, how do I even start? So if you start observe or trying to get your apps more observable, you say like, okay, like what do I do, right? Might feel a bit overwhelming. So the problem with this is that there's a lot of tools around, right? There's a lot of tools. They don't talk to each other. The way you configure them is different. They're not compatible to each other. So once you pick one, you're done, right? Let's say you have 100 microservices. You pick one library to instrument or one vendor. You go all the work of months of instrumenting this, and then you kind of locked in, right? There's no easy way to change, to send the data to a different. For example, you want to try a different observability platform. There's no way, right? You have to invest all this engineering power again. So that's not great, right? I guess nobody here likes vendor lock-in, right? And I keep telling you, okay, this is good. And then you say, but this is bad. This is good, this is bad, right? So like, please tell me there is a way out of this, right? This mess. And there is. It's the main topic today is OpenTelemetry, right? So OpenTelemetry is one solution for all of these problems, and we'll see why. So first, what is OpenTelemetry? So you might have heard of it, you might not, but OpenTelemetry is a open source, vendor neutral observability framework. So with OpenTelemetry, you're able to instrument your applications, generate telemetry data about it. So metrics, logs, traces, and maybe new types of telemetry data will come up. For example, profiling. That might be something that is coming up, the community is discussing. And so instrument, generate, collect and export this data somewhere else, right? And OpenTelemetry, and in the community we use, in the space we use OTel, because it's shorter, it's also cooler, nicer. So OTel is, I will refer to OTel for now, if that's okay for you. So OTel is the result of the merging of two other projects that you might also have heard of, called Open Census and Open Tracing. So these two projects did kind of the similar thing. So they were kind of competing with each other, and they say, okay, that's not really smart, is it? So let's join our forces and do something great. So that's what happened. So these two projects decide to merge, and then OpenTelemetry kind of, it was how it was born. Right, so we know what, hopefully, I was able to tell you more or less what OpenTelemetry is, but it's important to know what it isn't. So it is not an observability backend. It is not a visualization tool. It is also not an analytics tool. So OpenTelemetry is not a solution to send the data to. So it's not a backend where you ship the logs, to ship the metrics. It's only tools for you to collect them, to instrument, collect, and ship somewhere else. That's where the project, where this line ends in your infrastructure. And I know that in .NET, maybe I'm wrong, but I get the feeling that people sometimes don't really like open source projects, especially if you're not coming from Microsoft. So I put this slide to show you how big, how important or how relevant the project is. So this is a chart from the Cloud Native Computing Foundation, also from the Linux Foundation, which they belong together. So this is a chart showing that first, the OpenTelemetry is an incubating Cloud Native Foundation project, and that means that the term incubating might be a bit misleading, but it actually means that the project is stable and it's ready to be used in production. It is the second highest velocity project in the CNCF as well, and the velocity here means the chart here shows the number of commits, the number of PR and issues in the project, and the bubble size here is the number of authors in this work, so issues, PRs, and so on. And you can see that it's only behind Kubernetes. So Kubernetes is the first project, and then comes OpenTelemetry. So you can see how this is a big deal, right? There's this massive amount of other projects. And OpenTelemetry is backed by a lot of big names in the space. So Microsoft does a lot of contributions, Google, Amazon, Dynatrace, and many, many others. So there's a lot of brain power going on from a lot of from a broad spectrum of companies supporting and putting actually engineering hours like Dynatrace does on the project to make it better. Right. So what is a big deal? Why OTel is a big deal then? So let's just summarize then. It's one framework, one solution for all. You don't need to install many tools. That probably you saw with the big chart with many a myriad of tools. You don't have to worry about anymore. Just choose OpenTelemetry. That's it. The question is easy. It's vendor neutral. So once you instrument your code with OpenTelemetry, you can shop around. You can choose any backend that you want to send your telemetry data. You can send to Dynatrace. You can send to any other. It follows well-established standards. So the context propagation that I told you is based on a W3C standard that's called trace parent, and it is the default in .NET. So when you so like, for example, when you have your ASP.NET application, it's already built into the framework. We'll see later. And the way this works, it's already following this W3C. Before it was some proprietary IDs from Azure, but they switched, I think, in .NET 3.1 or maybe even earlier. Might be wrong here. But it's already there. So it's already using this standard. And again, as I said, it's backed by big names in this space. Right. So now that we know, let's say, the basics, I wanted to give you a quick tour about the OpenTelemetry architecture, because once you get started with it, it will be good to know how, like, what components are the OpenTelemetry project made of, and how or which one you use in certain scenarios, right? So the chart might be daunting, but we'll break down, so hopefully it's not that overwhelming. So the first thing that we'll check is the OpenTelemetry API. So the way I really like to think about this, and I guess you will relate to this as well, is that in .NET we have the iLogger interface, right? I guess all of us are familiar with this. So in .NET you have the iLogger interface, and With that, for example, you can create a NuGet package, and you don't care, for example, which log provider or to which backend the application consuming your library is sending the logs to, right? They might be sending to Elastic, or they might be sending to Dynatrace, or they might be sending to a text file. You don't care, right? In your library, in your app, you only rely on the iLogger interface. You just log. You just want to log things, right? With the OTel API, it's pretty much the same thing. So you install the OpenTelemetry API package in your .NET apps, and then you instrument it. You instrument it with metrics, with logs, with traces. You don't care which observability backend is gonna end up. You just instrument it, right? So it's pretty much the same. You just rely on the common interfaces, and that's what the OTel API is. And this image here shows that you have the meter API is what you use to produce metrics. The tracer API is what you use to produce traces. There is also the logs that's not shown here because it just kind of went public. And there's the context propagation again, it's also part. And there's a bunch of conventions, and this also like an aside, it's just a bunch of conventions for how, for example, to name things or how things should be. For example, how do I name a metric that measures the CPU, right? Because we want everybody to use the same terminology. So your experience when you move from place to place is the same, right? So this is what the conventions are for. And these are all part of the API. And similarly, in .NET from the iLogger interface, and then when you want, for example, to configure where you send the logs to, in .NET you configure your log providers, right? So in your application, you say, I want to use the file provider or the console provider or the Azure provider or any other provider, right? Or the FluentD provider or the Elasticsearch provider, whatever. It's the same thing again. So when you want to configure where you want to send the telemetry data produced by OpenTelemetry, you install the OpenTelemetry SDK, and then you tell it where you want to send the data, among a bunch of other things that is not really relevant right now, but you can configure like how things are processed, how they're bashed together and sent. But in the end, it's this. You can pretty much think it's as a close relationship with the log provider in .NET. You configure where to send it. And the nice thing with this architecture, this breaking of responsibilities, is that until now, it was not possible, for example, for you to write a library and have built-in instrumentation in it. So for example, you build a library, let's say that you want to build a library to connect to a database, for example, to SQL. You want to write your own SQL driver, for example. You can already put traces inside your library and metrics and so on. So when people use your library, they will already have, for example, how long a SQL query took or things like that. But you can do all of this, and so far it was not possible, right? Because you had to install this proprietary SDKs packages from the vendor that is going to end up, the data is going to end up on, right? So this solves everything. And the other nice thing is that, for example, if your app is not using if you're in your app, you didn't configure the OpenTelemetry, you didn't install the OpenTelemetry SDK, and you have, let's say, a lot of libraries that already have instrumentation built in, all this data is just a no-op. So like nothing will be produced, and there will be very, very low overhead in your application. So you don't have to worry, for example, that I don't know, the SQL drive that you're consuming is already instrumented, and you don't care about it, right? You should care about it, but could happen, and it will just produce no op. And that's how it's possible for you to only have the API in your libraries, and however they're going to be used, telemetry data is going to be produced. All right, so that's pretty cool. And then the last part is how you export it. So I said it's part of the exporter. So the exporter has, the SDK has something that's called the exporter, and there's many of them. And you can also build your own, is highly extensible. But in the SDK, they have the, let's say, built-in exporters. There is the OpenTelemetry exporters that produce data in the OpenTelemetry protocol in the format that OpenTelemetry dictates as well. So in your app, then you say, okay, I want to send this data to this place. So you can do it, as I said, in the graph here. You can send directly from, so this part here is your app. You can send directly from your app to the vendor, for example, to Dynatrace. Or you can send to another component that OpenTelemetry gives, which we didn't talk. Also, again, could be a talk on its own, but there's another component in OpenTelemetry that's called the collector. And basically what it is a component, it's a service, it's a Go binary that can sit in your infrastructure and act as a central place of ingestion. So you can send all the data to it, and then in the collector, you can again configure the same thing, the exporters, and to send to a backend. And the cool thing is that with the exporters, that you can configure multiple of them. You can configure to send to the console, to Dynatrace, for example, to another project called Jaeger that we'll briefly see. So there's a lot of flexibility. You're not locked into a backend anymore. You can shop around, you can configure. It's really easy to do. So that's how more or less the architecture. So first we have the API, then the SDK, and then again you have the exporters. Right. So now that you know this, let's finally dive in and see how this is related to .NET. So how can you use OpenTelemetry with .NET? So the first, just a little bit of how the project is, what's the support for it. So it works in .NET. You might know it, .NET Core. So, but now it's just .NET and the .NET Framework. It's only supported for .NET Framework that Microsoft itself supports. So no using in 4.5, for example. There is already a version out for the OpenTelemetry API and SDK stable, so a 1.x version for trace and metrics. Logs are coming. It's in .NET they kind of reused what they already have, the iLogger and things like that. So, but the OpenTelemetry itself, the API, it's still not stable yet. So that's why I didn't put it here, but it's coming along. There's already a lot of out-of-the-box auto-instrumentation packages. I will also talk about this briefly, that you can install, and they will already collect a lot of telemetry data for you. So, for example, there is auto-instrumentation for ASP.NET Core, for HTTP clients, and for many other libraries like Entity Framework, Hangfire, for Redis Cache, and so on. And there's also a beta version of an agent-style instrumentation. I don't know if you're familiar with this, but an agent-style instrumentation is like you drop in executable in your host, for example, and then install that, run that process, and then it will automatically inject itself into your running application and do all the work for you. So it will do the work of configuring the OpenTelemetry SDK, telling you where to send and all that. So once this is stable, you potentially don't even have to touch your code. Just run the agent and it will do all the work for you.
What is the accuracy of the agent?
Sorry?
What kind of accurate data can the agent gather? I mean, how he will know about the context and the events, the business events, in terms of metrics?
Yeah. So the agent itself, so it will inject itself into the apps, and there's already, for example, this is not a new concept. A lot of companies do this. Dynatrace does this, and it can capture a lot of conventions. For example, HTTP requests it can capture. It can get all the data. It can do the correlation, and so on. But it can also do, for example, in your code, if you start a span manually, it will also be able to grab that and learn and hook itself into the .NET runtime and picks up the things there, because when the .NET app runs, right, it runs into the code is in the intermediate language, and then the agent can hook itself into that, because it's not a compile like Go, for example, that you can do this. Like the agent can hook itself into the runtime and then gather all the statistics. It can see the code. It can add more code on top. It can auto instrument for you. It can, for example, it knows that there's an HTTP record that starts here, so I will start a span here and end here. So that's more or less how the agent works. It's also very complex and things like that. Yeah, but there's a version out. It's beta. You can try. Right. So I have this chart here just to show also an idea. This is from the project I mentioned, the NuGet trends, that you can see the download rates. So here you can see, for example, the download rates of the main packages, let's say the API, the SDK, and the ASP.NET Core instrumentation. So you can see that there is like 60 million downloads in the last 2 years. So it is only growing. So this, you can see that people are really adopting this. Yes, and in .NET there is some peculiarities. Just go quickly on this. And if you start, for example, if you already use OpenTelemetry, let's say in other languages, or if you don't use, but you start reading about it, for example, in the specification, and then you start using it in .NET, you'll see that the terminologies don't align much. And that is because .NET already has built-in support for traces in the runtime itself. So it's in this package, the system diagnostics package. So when you use it, it will work the same way as you would use in any other language, but the terminology is different. So I just wanted to mention this because you might say, oh, okay, but the OpenTelemetry specification says one thing, but when I use it, it's called something else, right? And that's why. It's just basically a history thing. And they didn't, of course, they didn't want to redo everything in the runtime because that takes time and so on. So they kind of repurposed it, and that's how it is. And if you're not happy with that, you want to use the same terminology because that would make sense, right? Then there is another package called the Hotel Tracing Chain, a NuGet package. Then if you install that, then it's just a wrapper on top of the system diagnostics that use the same terminology as Hotel does. So then you have nice and tidy terminology across your whole of services. Okay, so how do we actually use this now? So hopefully things were a bit clearer now. So let's see how you know what Hotel is, what the SDK is, and the infrastructure, the architecture. So let's see how actually you do this. So first you need some packages, right? NuGet packages. That's pretty much inferred, right? So you install some Hotel NuGet packages, and here are, let's say, the bare minimum that you would need. You install the ASP.NET Core instrumentation and the HTTP instrumentation that will instrument outgoing HTTP client requests in your code. The extension host is just the common .NET thing that you have this extension methods to make things easier to configure and nice. And then on top I have the exporter. As I said, I picked the OpenTelemetry protocol exporter, but as I said, you can pick more. You can add, for example, the console exporter. I can have any other. I can create my own, for example. Right, and the version here you can see that alpha is allowed, but it was stable. So the instrumentation code is not stable, but the API and SDK is. And the reason why you don't see the API and SDK listed is because, as you know, there's a transitive dependency in .NET. So the ASP.NET Core depends on the SDK and the API. So by installing this one, I already got the other one. So that's why it's not listed here, but it's inferred that it's there. Right, so after you have the package, then you need to configure the SDK, right? And this is also like broke some lines or something, but it's really not a lot of code. So you call add OpenTelemetry tracing, and then you tell the source of it, and then you can see the two lines there. I added the HTTP client instrumentation and ASP.NET instrumentation. I told it to record exceptions, and I also add the entity framework core instrumentation to find out about my SQL statements, SQL requests. And at the end, I say, okay, I want to send to OTLP. I want to use the OTLP. The OTLP means the OpenTelemetry protocol exporter. That's the short of it. Right, and then this is for traces. And for metrics, it's pretty much the same. I just changed the name to add OpenTelemetry metrics. Again, I add the instrumentation packages that I want to collect metrics from. I can also add the add meter there is adding a source for collecting metrics from other places. For example, this is from my app. I want to, because my app also produces metrics. So I want to collect those, of course. And in the end, again, I say that I want to export with the OpenTelemetry protocol exporter. Right. So, okay, we have the packages, we install the SDK, and how do you actually produce the data, right? So to produce traces, for example, you can just use this potentially two lines you only need. So first you start the tracer. So in OTL terminology, it's called the tracer, but in .NET it's called the activity source. So you see already the mismatch in the name. And then with the tracer, then you can create spans. And as you remember, the spans are the operations that are happening in your app, right? So you start a span, you start an activity, and you can give it a name. For example, I gave it some operation. And then with the span, you can add tags, you can add attributes to it. So for example, I add there the user ID that is incoming on my request, for example. You can add anything that you want, right? That is relevant for this operation that you're executing. You can also add events, for example, like I did here. I add an event saying that the user does not have the permission, the required permission. And you can also set manually the status of the spans. For example, if you know the operation failed, for example, you can set it the status as an error, like I said here, like I did here. So this here will produce a span with the attribute user ID with this event and will be an error. And for metrics, it's pretty much similar. So again, you use a meter, and the meter is what you use to produce metrics, to create metrics. So I start a meter, I call it my app. Again, I added a version to it. And then in the second line, you can see that I, for example, use the meter to create a counter. So to count things, right? I want to count the number of fruits that I'm seeing in my app. And then with the fruit counter, then you can do fruit counter add, and then you add how many you count of this thing, right? And you can also add attributes to the metrics. Like I said, like I did here, I add an attribute called name with the value apple, and an attribute named color with the value red. And if you use metrics already, these are as also known as dimensions, so you can split the metric. For example, you can split the metrics by name, and you see the fruit counter metric by the attribute name, and see how many fruits you're counting. For example, apple, oranges, bananas, and things like that. This could be, for example, how many items you still have left in the queue, for example. It will be a metric. Okay, so that is pretty much it. I have prepared a demo for you. Hopefully it works. So I just wanted to briefly talk about what the demo is about. So I guess maybe you are familiar with Identity Server, this OpenID certified secure token service that gives you access tokens, for example, you can use to protect APIs and things like that. So it's the service consists of Identity Server sitting there and our API. And basically our API uses the access tokens coming from Identity Server to authenticate the request. And then there's a database, SQL database that has the user's permissions. And then our app gets the permissions, check if the user has the permissions, and then gives the result or not. So that's basically it. So I'll switch now to the demo. Right, so here we have our app. It's pretty simple. It's just a Swagger. It's just a bare bones ASP.NET Core API with Swagger. So here we have the page, and I have everything running. So I have the .NET app running, Identity Server running, the SQL database, and I also have the OpenTelemetry collector that I briefly mentioned to you. So all the data, all the telemetry data is being sent to the collector here in my Docker compose. They are all running here. So I will first then log in into the app. So I'll log in as Bob. Right, I'm back. Swagger has my access token. So I will first call the get endpoint, and I left a hint here saying that Bob and Alice can call this because they have the read permission that's required for this endpoint. So I'll try it out, and it works. We have our response. We got the products, right? So I'll try again now, another endpoint that requires the create permission, and Bob does not have this permission. So this should fail. Right, it fails. So Bob is not authorized to make this request, the post request. So now that I generated some data, so I did this request and so on, so I'll show you how the trace looks like, for example. So first I'll show you on Jaeger. I don't know if you're familiar with Jaeger, but Jaeger is an open source tool that you can use to send your traces to and then visualize them. It's pretty cool. So it's really lightweight. You can run as a container in your machine, and you can quickly see things for development. Right. So here in Jaeger, you can see that there is a way to filter by services here. So I already have my API service filter, and we can see the traces for it. That's the one that I just generated. Just for matter of timing, I already selected the trace that I recorded, but it's the same thing. Not sure if this is big enough. I'll make it a little bit bigger. Right. So here we see the whole trace. This was just a GET request that I did. Right. So there is a lot of information here, and try to make it smaller. Right. So you can see here that the blue line here, the blue thing, the blue item here is my API, and the yellow is Identity Server. And the Identity Server project already has OpenTelemetry built into it. So the authors, the creators of the creators of Identity Server, they already instrumented it with OpenTelemetry. So the only thing that I have to do again, I told it to where to send it to, and I told it to send to Jaeger in this case. No, I told it to send to the collector. I will show you later. and the collector is sent to Jaeger. So just because of that, I have all this information here about what happened inside the identity server. So when I made my request, the ASP.NET API had to, for example, check the tokens, if the token is valid, check the signature of the token, all that stuff. So you have all this information here already that have inside identity server. I didn't have to touch anything for this to work. Right, so I'll just collapse this for now. I hope you see the power of this, because like I used identity server in the past and it was not easy to debug when things went wrong on it. It's really complicated. I had to look at the logs. It was kind of a mess, and this is like a huge deal because you can just look at the operation and see, for example, who is taking too much time or which operation is failing and so on. Down here, then I have again our API. So we got the tokens valid. Then we start checking the permissions, right? So as I told you before, I instrumented the app with Entity Framework, the instrumentation for Entity Framework, and then you can see here the SQL commands that was executed by Entity Framework. So it's pretty cool. You can see your queries. You can see some, like I said, the span here has attributes. So you have the host name, the address of the host for the database, which is the library it is, what version, and so on. And down here as well, I have some manual instrumentation that I did because my app has some custom authorization policy going on in ASP.NET. So here I created a manual span. And in this one, for example, you can see that the name of the policy. I don't know if you're familiar with policy authorization in ASP.NET, but you're given a name for the policy, and then that policy is evaluated. And here is when the policy was fetched, and the policy is this. It's called permission. And the way it does, ASP.NET does, it concatenate everything into a string because it needs to work with string for the policy name. So the policy is permission, and it requires the one here means the operator, so it's and or. So which kind of permissions it requires. So it requires only read here, or only read permission. And then at the bottom here, we have when we actually handled the authorization request. And then here we can see that it was a success because the span status code is okay. So everything worked. And then we saw that worked. So I also did a request that failed, if you remember, right? The one that was unauthorized. So that looks like this. So we don't have anymore the whole identity server things here, because the token is already valid. The identity server knows about it, is already cached. So that thing, the whole thing doesn't happen every time, thankfully. That will be very slow. But we still have our database call here, like we saw in the other one. The SQL commands are here. And the difference here, you can immediately see that something went wrong here, right? So when the policy was being evaluated, it failed, right? So the span here says errors. And in Jaeger, it's not possible to see logs, because it's not a logging. I think they might be working on this. I think I read something, but it's not here, right? But just to prove the point then that without changing my app, I can send the telemetry to another place. I will show you how this looks like in Dynatrace. It's not advertising just because I have a license and I can show you a different backend. So here is, I'm also filtering like I did in Jaeger, filtering from my API service. And this is the distribute traces page in Dynatrace. And then I see all my spans here, all my traces here, right? All the operations to the products endpoint. And again, I also selected one to show you. And this is really big. And it's the same here. So we also have the whole identity server things happening like we did in the other one. I'm not gonna show this again to you, this collapse. But here, what is the cool thing is that Dynatrace supports logs, right? So the logs are also coming to Dynatrace, and what I can see then here, for example, in the database call, I can also see the statement like we did in Jaeger, but here I can also see some logs. So these are logs that came from Entity Framework itself. And then, for example, in my own manual instrumentation, I also logged that the user was authorized. So we can see here as well the log that I did. So we can see I logged the user has the required permissions, right? So this worked. And I'll show you the one that didn't work, the same thing. But here in the log for the fail, you can also see immediately that it's red, that it was a problem, it failed. But here without having to check anything, right? I just switch the tabs here to the logs, and I can see that I record this log, and I can see that it failed because the user did not have the create permission. So I can see it right here. Right, so that's that's pretty much it. And just to show also a little bit of metrics. So also sent to Dynatrace because it's easier for me. So this is the metrics come from the ASP.NET instrumentation. So this is the HTTP server duration for the request. So for the product's endpoint. So this is here, just so you can see that I can also have metrics. And I also didn't have to do anything. I just installed the ASP.NET instrumentation, and that was automatically collected by it. And here I can also did custom metrics because I wanted to count, for example, how many authorizations I'm doing in my app. And so this counts the number of, the purple one is the one that was authorized, and the yellow ones that are on there that failed. So we can see here as well. So we can create alerts based on it and all that stuff. All right, so that is it for the demo. I guess, I'm not sure, do we have time for questions?
We have time.
Okay, so now you can make your questions. Hopefully I can answer. Right.
Yeah, I don't really get it how you, say for instance, you start, for one thing is, if you start a span, it's still manually, basically. You have to know where a span, what you define as a span starts for you and where it ends in the code. You have to do that. And say, for instance, the span goes across several services, distributed services. How do you correlate the span with another service? How does the other service know about which span you're talking about in the first service?
Right. Okay, I will repeat the question to the audience. So the question was, do I have to, I think there was two questions.
Yeah.
So the first one was, do I have to manually start a span and end it? And do I need to know where this happens? So this was question one. So this is, you're right. So if you do manual, so if you want to do any manual instrumentation, you have to know where the span starts and where it ends. So this is the goal of it, because you are the author of your app. You know, for example, that this operation is important. I want to know about this, right? But if you, for example, using the auto instrumentation package, you don't have to do any of this. It does all for you.
There would have been another question, actually. I mean, it sounds highly magical.
Yes.
I mean, how the hell do you know
yes. So.
HTTP request is?
Yeah. So the
for
second.
Instance, is, you open your own socket and send an HTTP request. How does it
Yes. Yeah. So the second question, I think the second question will answer this. So the second question was, if I got it right, was how does this all work, right? So if I start a span in service A, how does service B knows about the span? This was the second question, right? So this is what I briefly mentioned about context propagation. So for example, when you start a span, so let's say you have an incoming request. So the request came into your app, and then, for example, you want to start a manual span, for example, to trace this request. So you start a span, and then inside this operation, you say you want to call, let's say, a feature flag, to get a feature flag from somewhere. So you make an external request, right? Yeah. So what happens is when you start a span, that ID that I showed you, the trace ID is created. So you create a span ID, actually, it's not a trace ID. You start a span ID. You create a span, and then a span ID is generated. And then when the outgoing request is going to the feature flag thing, the HTTP client instrumentation has a way of hooking on the outgoing request. So he hooks, and then the .NET Diagnostics package has a way to tell you what is the current span. So what is the current activity that is going. So if you have a block your code, for example, if you have your block of code, you receive the request, you start the span, and then you make the HTTP call, right? So at that point, there is an active span, right? Because you started one, right? Mm-hmm. So the instrumentation there sees that there is a span active, and then takes the IDs that it created and then pass it on as a HTTP header to the next request. So this goes to the other service over the network with the HTTP header called the trace parent, and these IDs are there, right?
Oh, okay, I see. But does that mean it only works with HTTP requests, or could you have something else as well, like JSON RPC?
Yes, it also works with gRPC. Yes, it's also use headers in gRPC. It's the same. Use the same key for the headers. The same value. Yes, it works the same way. Yes. And then the server that is receiving this, if it's also instrumented with OpenTelemetry, you will see that there's this header, and it's like, okay, there is a request.
I get it, yeah.
Yes, so it will. So just for the string, so the incoming service then will recognize that there is this operation going on, and it will continue. So it will set the incoming one as its parent, and then from now on it will do whatever it needs to do, and then that's how you do this magically thing. Yes, that was a very good question.
So this is to propagate these IDs via an HTTP header.
Yes, exactly.
Is there anything outside of HTTP that you can use to propagate this, or is that the only way?
Yeah, that is the standard. So that is coming from W3C, the standard. So the standard is to propagate these headers.
Okay.
Yes, and the goal is that everybody should use the same thing, because then it doesn't matter which backend you use or anything. So the problem so far was that each backend vendor had its own ID for this header. So everybody already did this way. So like, for example, if you use application insights, they already did the same way, but they had their own ID for the propagation for this header. And the problem is that, for example, if you use application insights and I use, I don't know, Amazon or Dynatrace, then the problem was that they didn't talk to each other, because when I received this in my app that used Dynatrace, the trace breaks because it doesn't know about this, right? It can't continue. So the goal of using the standards, the W3C standard, is that no matter which library, which backend you use, you will be able to continue the trace, right?
Yeah, but it just basically comes down to the fact that you're restricted to HTTP. I mean, there's nothing else that you can use.
gRPC is also supported.
gRPC supports
gRPC,
also, yes.
okay.
Yes.
But you have to use a protocol that supports supports propagating those IDs.
Yes, exactly.
Not necessarily. So if you have a messaging system, then you send the message somewhere, usually along with the payload. You can also add some metadata there, and then it would inject the span ID and the trace ID with the message. It would adhere it to the web messaging system. And when it's retrieved again, then the instrumentation would know where to read the IDs from. And
yes.
Okay, it would even work if you also persisted of these communication channels and somehow get the ID.
Exactly. Yeah. So just repeat here again. It's based on protocol, so it's based on headers and things like that. But there's also other ways that you can do. For example, for messaging, this IDs goes inside the message, because the message travels through different systems, different hops, different intermediaries, and then the message is the carrier. It's not a HTTP header anymore. So the message carries this ID, so be able to continue it. But the standard for HTTP, for example, is the headers, right? There's other ways. The message, for example, the messaging example is being specified right now. So there is no standard for this. There is also W3C group is working on defining a standard for messages for MQP and MQTT. So they will tell where to put in the message, how it will be named, and how this is propagated. So they're working on it. So that will be more than HTTP headers. Yes.
Okay, I'm more interested in Dynatrace.
Sorry?
Dynatrace. So it will be nice if we can look on the dashboard and linking stuff together. Because I believe it is the only solution, as claimed, to be able to show the traces as well as the metrics and the logs. So I'm more interested in seeing that in life.
Yeah. So the goal of the talk was not to advertise or show anything on Dynatrace. I'm sure that we can figure out something together that I can show you, or we can figure out something. Can make you the context, and then we can show you. But right now I don't have anything prepared for showing this to you. I'm sorry.
Yeah, I have a question. Can we use can we create span for several trace IDs? What I mean, so imagine we have service, so we have upstream service, and we consume Kafka topic. Yeah? So we consume messages from upstream.
Right.
And each of message, okay, has this correlation ID or trace ID.
Yeah.
But what we do in our microservice is aggregation. So imagine we collect, I don't know, per second, dozens of messages.
Yeah.
So and now we generate new message for downstream. Which trace ID should I use, or it's not impossible at all?
Right. So so the question is, let's see if I can repeat it. So it was kind of complicated. Yeah. So so the question was, how can I what else can I use as a trace ID when I have, for example, a batch of messages? Let's say like that, something like this, right? Because what I showed you is that the way it works is that you have a direct parent and child relationship, right? For the operations. So one operation can only have one parent, and the way OpenTelemetry solves this is with this called as links. So with the link, you can link a trace from another trace. So I guess in your case, you would be able to use links. So when you receive all the batches, so when you receiving the batch of message, you bulk them, right? And then you can start a new trace for example, processing them. But if each message has a correlation ID, has a trace ID inside, you can add all of these as a link to the span that you're starting. And then you'll be able to navigate from one to the other. So you can see from the processing where the message is coming from. So you can click and you go, click and go. So this is also
Standard
still.
parent ID? This link is parent ID, or how it works? Or it's attribute of tag?
Yeah, so you start a span and you say add link, and then you add the ID, the trace ID of the other trace to it.
And yeah, and all UI tools understand this and
Yeah.
will display it fancy.
Yeah, so this is a bit of a problem right now because it's rather new, this concept, and not all the backends have, let's say, native support for this, that you can do like things like you said, like I can quick navigate and go back and forth. But the community expects that this will happen, right? So because they introduced this now, and we expect that people, that vendors and platforms will start understanding and build the UI so you can do this type of things. Yes. Yeah. So I am actually working right now in the messaging group in the specification that is trying exactly to solve this problem that you have. Yes, and we're looking for people that actually work on these things and are suffering from these things. So one thing I didn't mention is we have public meetings. So OpenTelemetry is all open. We have meetings every week, and anybody can join. So for example, you can join, and you can tell your pain, what you would expect to see, what you would like to see, how you would like to use, because we are engineers working on it, but we don't really get much feedback from people that are actually going to use this, right? So you can go to the community repo on GitHub, or the OpenTelemetry community repo, and then you can see all the meeting times, the agenda, and you can feel free to join. There is also a Slack channel. You can drop messages, for example. Yes, in the back.
Yeah, Mike. Is there a good way to integrate SQL Server into OpenTelemetry? That which I mean is SQL Server itself has tracing capabilities, and yeah, we are always looking to get the information from SQL Server traces integrated into the rest of our logging.
Mm-hmm.
So the question is, do I have any chance of getting the trace context to SQL Server and getting the SQL Server traces reported to OpenTelemetry?
But do you mean things from inside this actual SQL Server code, or from talking to SQL Server?
The SQL Server traces, when you run a SQL Server propeller and get all the SQL Server statements.
I see. Okay. Yeah. So that would require that. So okay, I'll repeat. So the question was, can I get distributed tracing from SQL Server itself? For example, when I run the profiler and things like that inside SQL, right? That was the question. Okay. Not when you talk to SQL, for example. So that would require that it is possible. So it would require that the SQL Server people built in instrumentation inside SQL Server and offer you a way to configure where to send it. But it will be possible, yes. If they do it, it will be possible. For example, it would be possible, for example, if you also have some other, let's say, black box thing, that if that is instrumented, for example, then you would, for example, like identity server, for example, they instrumented with OpenTelemetry. I just configure it, told it like send to this backend, and then it worked. So it would be the
unless the SQL Server team at Microsoft is a business case.
Yes, exactly. Yeah, yeah. So they would have to do it. Yes, there's no way around it. Yes.
Okay.
There is already support in the OpenTelemetry collector to receive SQL Server metrics, but I don't think there is any correlation with traces, but technically it would be possible.
Yep. All right, any questions?
Good. Yes, we got some questions from the stream.
Right,
so
on fire today.
The first one is about a little bit about Jaeger, what you showed.
Okay.
If you would like to know the difference between Jaeger and OpenTel and which one will be more suitable for .NET apps.
Right. Okay. So Jaeger was a Jaeger also offered SDKs, so you could also install the Jaeger SDKs and produce traces from it and send to it. But the direction that the community, even the Jaeger community, is the Jaeger project is going is that you should use OpenTelemetry. So you should install the OpenTelemetry SDK, the API, the SDK and APIs, and use telemetry data produced by OpenTelemetry. It is so much so that the Jaeger itself now, there is an endpoint in Jaeger now that receives native OpenTelemetry protocol. So you can send directly from your SDK producing OpenTelemetry data directly to a Jaeger instance. It will accept it. That's how big they are in OpenTelemetry. So and what I see around the community, I would tell you that just go with OpenTelemetry. That will be best for you. And again, in .NET, there is already built-in support for it. So with the diagnostic package, so you don't even need to install any OpenTelemetry if you just want to produce traces.
Good, thank you. And the second one is almost two questions. First one is how to write instrumentation without overloading the main code, and how can the person enable and disable tracing?
Right. So the first question, it depends, right? It depends what you do, right? So I guess it depends on your own use case, what you want to do. You have to know what kind of operations is important for you to know. It's not because you have this possibility that you're going to start putting tracing everything, right? You don't want to get also overloaded with data, because that is also not useful. So it don't really have an answer, but I would just try to think about what operations actually mean something in your business. Like, is this operation crucial for me? Do I want to trace it? Yes. Is this just some check? It will be similar, for example, when you log something that is just info to something that is, for example, a warning or something. If something is important for you, I would trace it. Otherwise don't. And the second question was, again, sorry, was?
How to enable disable
Okay,
tracing.
so this is, I think, not possible today, but there is a PR open now to add environment variables, to add one environment variable that you can use to tell if the SDK to be disabled or not. So you will be able to switch this environment variable, and then everything is disabled. But it's not merged yet. So after the PR merged, so the PR is in the specification, and after it's merged in the specification, then the library, the language implementations have to implement this. But once in the specification, then it's not really, it doesn't take too much for it to be implemented. So that will be done after that. So you will be able to disable.
Good. That were the current open questions from the stream, as far as we see here.
Right. Then
there's one here in the audience.
Right.
One question regarding, so on one side we have an application which uses Hotel API to produce something.
Right.
And on the other side we have some backend where we store this data.
Mm-hmm.
And there is the case in between which basically transports telemetry data.
Right.
That means, or that basically requires that there should be connectivity between the application and the backend.
Yes.
So are there all the SDKs implemented in this way, or are there any solutions like, I don't know, with login? It's quite a common practice that applications is logging to the file or to container output, and then there is in between something that kind of decouples the application from the
right. Yeah, so there is, so you're right in your assumption. Let me just go back to the slide. So here, so when you install the SDK, you can configure an exporter, right? So if you configure the export to send directly to your backend, then you need a connection to your backend, right? You can still optimize it, for example, to batch the operations, to not send like every time, to not have million requests going on. So you can say, I want to delay a bit, I want to batch, I don't know, 1,000 records or 1,000 metrics before I actually make the call. So that is also possible. But the other thing that you probably will be able to solve in your case is that you send to the collector. So if you have a collector as a sidecar, for example, like the colleague said, in your infrastructure, then you send to the collector, and the collector can act as a main central point of ingesting the data. Not aware of a way to send to store as a file, for example, but the common practice is if you don't want to, for example, overload your apps from making HTTP connections to potentially long answer that's sitting somewhere else, right? You can just make a local call. Maybe it can even be like a gRPC call to the collector in your local infrastructure, and then your app is done. And then from that point on is the collector job from doing the calls.
Which guarantees do I have regarding that all my data will be in place in case applications crash, in case network is crashed?
Yeah, so some of this is the SDK responsibility. So not sure if there is any way. I think there is a way for retrying, but there's definitely ways of retrying in the collector, for example, if something's failing, same because the backend is down or something like that. So there's a lot of ways. The collector is really powerful, so there's a lot of ways of building some sort of resilience into it. So you have less chance of running into the problems that you said. Right, there is one in the back.
Is the OpenTelemetry collector a finished component that is provided by your foundation, or is it rather a specification and can be implemented by various companies?
Right. So I forgot to repeat the other question. But this question was: is the OpenTelemetry component, is the OpenTelemetry collector component is something that is finalized, or can I build my own collector? That was it, right?
Or are there other alternatives on the market?
Right. So the collector is a component, right? So, and there is ways, for example, for you to fork the project, and they have a structure actually for doing this. So you can fork the project, change it the way you want, because the collector has a lot of modules. For example, it's a Go application, and it has a lot of modules. For example, Dynatrace has its own components there. So, for example, you could fork it, remove all that stuff because you don't care about it, add just to your own thing, and produce a new binary. That's totally possible for you to do. And there's a lot of other companies there are other people. For example, AWS has its own distribution of the collector. So they did the same thing. They not fork, but they have their own project, which basically downloads the Go binaries because it's public. It's just a package, right? So they download the Go the collector packages into a new project, and then they build their own. They call it the AWS distribution, which is basically a collector pre-configured to work with AWS. So there's companies doing this already. We're seeing that it's being something that is quite common actually. And as I said, the collector repo has instructions that's actually for you how you can do this. So it's not something that is illegal or a workaround or something. It's actually documented, so you can do it. Cool. Right.
One last question.
One last question. Okay.
In addition to disabling, so
okay.
What if I don't care about some component? I think okay, HTTP is fine, but database I don't care. Can you disable in general way, like onto this entity framework?
Yes. So I mean, the easy way is like you don't install the instrumentation, right? So if you don't care, you don't install the instrumentation. Yeah, so in my case, I install a package. So I have to install the auto instrumentation package for HTTP framework. But for example, if I have some other agent or something else, there's in the OpenTelemetry SDK, there is ways for you to filter things out. So for example, I had the Swagger page going on, and there's a lot of, like if I just open the Swagger page, I have requests for the Swagger JSON file, for the fave icon, for some XML, whatever. I don't care about those, right? So in the SDK, there's a ways for you to filter things. So you can filter, it's quite powerful. So you can pass a function to it, and you can basically tell it how to ignore things. So for example, you can ignore everything that is coming from the SQL library, for example. So you can do that. It's possible. And you can also do that in the collector as well.
In the demo, there was also a method which we called ourselves into the framework instrumentation, which means that if I do not call it.
Yes, exactly. Then they will not get, yes. But what the colleague was saying, that maybe this is not done by you, it's done by someone else that you don't have control, for example, then you can uninstall that package, but you can filter out. And you can also filter out in the collector if you, for example, have 100 apps and you have to do this manually everywhere. So you just do in the collector, they send all the collector, you can filter out things there.
But I can do it by name, yeah, by stream. Or
you can do by
some levels.
You can do by many things. Yes, you can do by the name of the library that is producing. You can do by based on maybe some attributes or things like that. Yes. Okay. Right then, let me go back to this and That's it. Let's stop this.
Can I go? Can you go back to my slides?
And
Now, trying to convince him with the same presentation and the same
look at this over here.
Wait, where are you going? Joao, where are you going? So, yeah, I also want to say thank you
Yes,
for
you're welcome.
doing here, and every speaker at our meetups gets our logo as 3D printed coaster. So here you are.
Thank you.
Only the first talk.
Nice. Okay, that's enough. Good, thanks. I always want one of these.
Thank you all for joining, also on the stream. Again, thanks to our sponsors, Dynatrace, for hosting today here. I see already the food there, so I will try to be quick. Also, thanks to Rubicon, Telemetry for sponsoring, and the JetBrains. We will raffle the JetBrains license then afterwards. Quick, if you want to host a meetup also, or your company, please contact us on the site or talk with us now. Always looking for locations for the next meetups. And speaking of next meetups, October is still open. But we have already one for November. We are to talk about SignPass, and we will be at Rubicon again. One thing I would like to ask you is, please spread the word that we are doing these monthly meetups. Invite your colleagues, your friends, simply everybody who you think has to do anything with .NET. And again, you can find us with website, Twitter, Twitch, YouTube, where the recording of this session will be available immediately after we press end, and also the Slack channel to help each other. And one last thing is, we always want to improve our meetups, our events. So it would be cool if you give us some feedback, QR codes for the persons here, the link in the chat from Stefan. Please give us some feedback. We want always improve our meetups. And with that, again, thank you for all, and see you next time.
I forgot to mention, but I will somehow give the slides to you. Maybe I don't know how that's usually done, but
Yeah,
but I will also. So the